interesting, let's say. Chocolate cake. Ushuaia, discotheque in Ibiza. Early bird, usually. Like having colleagues from all over the world, for example.
Hi everyone, it's so nice to see you here again. Welcome to another episode of Next Gen Scientist at Institute of Science and Technology, Austria. Join me and take a look at the science and the scientists in the making at HISTA. And today, sitting on the purple couch, I have Giovanni Brigati. Hi Giovanni, welcome and thank you for being here.
Hi, thank you for the introduction and good afternoon.
So, you are a mathematician and you will tell us all about what brought you here. But I know that you work with something called kinetic theory, right?
Right.
What is that all about?
So, kinetic theory is a mathematical description of systems of interacting particles or agents like a gas, a population of bacteria or of stars or humans. The idea is that you have many objects which interact one with each other.
Oh, okay. Would you like to maybe tell us a bit more about it? Because I know that you prepared something really cool looking for us.
Yeah, so I prepare something which goes in the direction of thermodynamics. So it will be an explanation of kinetic theory applied to the theory of gases and fluids, actually, which are perfect models covered by our mathematical framework.
Let's take a look.
Yes, let's go.
So we are here in our improvised lab bench, and I see that you brought with you some milk, coffee, and what looks like colored paper. So how does this relate to your work?
Yeah, so as I told you before, we are very interested in the mathematical description of these interacting particle systems. So I prepare something for you, and most of all, I would like to tell you about the second principle of thermodynamics, which is one of the key laws of the universe and of our subjects. So here, this is a description saying that if you take one of our systems, you will see that disorder will increase over time, always. This is the statement of the principle. And now I prepare a toy system and a more realistic system to discover together how it works. So here I made these paper balls in two different colors, and you see that if I take some yellow ones and I put them here inside, and also I take some red ones and I put them on top of the yellow ones, you see now those are well separated, and then we close the system and we start with the interaction, and you see that they mix very easily, while we won't think that if we take those and we continue mixing, they would go back to the previous state. You see this, we cannot go back in a disorder. And from this we understand that the universe likes very much mixing, and it's hard to separate, because separated things come with much more information, actually. Here I can say, okay, I have yellow ones and red ones separated, and I can even describe it to you. And this, what should I say? It's just a mixture. So less information, and the universe is very lazy. So it's easy for the universe to be in a less informative state, because it's just easier to keep and to maintain. And so if we want to go back in this model, you see that I have to do quite some work to separate them. Like at home, it's easy to have the house in disorder, but to tidy it up, you need a little bit of work.
You need to spend a lot of energy to go from chaos to order again.
Yeah, exactly. And if we add more particles, more agents to our system, you see now we have a lot of them, and I put them together, and So this is even more informative. More red and more yellow separated. We mix them up, and you see that they mix even better, and it's even more unlikely that if I continue mixing, they would separate again. So the more the particles, the more what I'm saying here is true. And actually, kinetic theory is the description of a system where the particles are many. This is what I told you before. So these are not that many. But actually, in kinetic theory, particles are so many that it's basically as if they were infinitely many. So like, for example, in this coffee glass, I have around, let's say, 10 to the 24 particles. So there are more particles inside here than stars in the universe, for example. So there are so many that we consider them to be infinite. So what we showed here should be even more true with such fluids made of many, many particles. And now I show you how well two fluids mix. Yeah, one. So these are like yellow balls. Let's add the red balls, milk on top. It will already mix a little bit. And now we start the interactions in the system. Yeah. And now the two fluids are perfectly mixed. They mix very well, and the particles are so many that basically it's impossible to separate them. We will take a time and an energy which is by far beyond the time of life of the universe, for example. So actually, we see how disorder gives an arrow to time. There's past and future. There were milk and coffee. Now we have this mixture, and we cannot go back in the past again. So there's an arrow in time given exactly by chaos. And this is how the second principle of thermodynamics works.
It's very cool. So we all go from order to chaos and also towards breakfast.
Yeah, that's right.
Okay, shall we continue our interview?
Yeah, with pleasure.
So thank you for showing us this very cool experiment. If someone would like to maybe try this at home, what would they need?
So actually you need two sets of objects you can mix together and see what happens. Or if you wish to do something more spontaneous, just tidy up everything and then let disorder come into the home for a few days and you see it.
So anyone can really experiment a bit about chaos and kinetic theory at home.
Yeah, it's around us in every day of our life, I would say. So yes.
Yeah, so do try and then let us know how it went. So in order to now study kinetic theory like you do, first you needed to become a mathematician. So I would like to ask you if you know what was the turning point that made you think, oh, I want to be a mathematician?
So actually, it was many years ago, like in the 90s when I was a kid. And at some point, my dad told me this story about insects waking up every some number of years. And this number was a prime number because their predators were also waking up every other number of years, which was also prime, so that you minimize the possibility that the predator and the prey meet, otherwise the insects will be extinct. And I say, yeah, this is cool, and I just wanted to do that for the rest of my life. Even at school, it was my favorite subject.
Prime numbers in particular, or math?
Math in general, but prime numbers were fascinating for me because they were so unique and rare, and also still nowadays it's a major challenge to understand how they are distributed among other numbers. So this is still very interesting for me.
That's very cool. And I love how it relates to something completely different from math, which is the relationship between predator and prey. Everything is connected, really.
Yeah, that's true.
And so to do what you do today, what did you study? What was your academic path so far?
So after schools, I'm from Pavia, a city in the north of Italy, and I studied there until my master's. So I did a bachelor's and master's in mathematics at the university, and I also followed the courses of the Institute of Advanced Studies in Pavia, which was giving some complementary lecture. Then in 2019, I moved to Paris to the Université Paris-Dauphine, where actually I met my mentor, Professor Jean Dolbeau, who was my PhD advisor, and I stayed there 4 years to learn more and study with him and work together.
And your PhD was also in mathematics, or what was the specific subject?
So actually the PhD was in applied mathematics. So yeah, mathematics with a focus on kinetic theory, and there were also 2 other subjects altogether.
And so altogether, how many years of math did you study?
So if we started with the first year of university, I studied 9 years before starting the postdoc and being a researcher, yeah.
Very well. And in truth, we never really stopped studying.
Yeah, that's true. Yeah.
Great. So, what do you think that was the hardest thing that you had to do to be in your position?
So there were some hard points, but I think that one of the hardest points is when you pass from being a student at the university to a PhD student, because you have to start doing research, and in the first days my director gave me some papers to read and I didn't understand anything. I say, yeah, it's so different from studying at the university, so actually you have to get used to more current topics and yeah, and get used to actually professional maths with respect to studying. Yeah, so this was a hard point, I remember.
So, giving this leap to become independent in doing your research.
Yeah, this is complicated, but then it's a great satisfaction if you do it. But of course, it's an investment of work, time. You have to be a bit more sure of yourself, which is, I think, you grow as a scientist and as a man or a woman at the same time.
Yes, definitely. But very importantly, how do you think that you overcame or maybe are still overcoming this issue?
So one thing which helped me a lot was trust in intuitions and ideas very much, because maybe you read the research of someone else, but you make your own idea out of that, and writing ideas and try to give your own taste, interpretation, and try to re-elaborate in your own way on what you read actually creates some independent thought. So yeah, as I said, it's at the beginning you don't know how to do that, but then naturally it starts, and you have to follow this voice of intuition inside of you, I think.
Yes, I believe that like anything in life, it's about just doing it, and you will always make mistakes, especially in the beginning.
Yeah.
But throughout time, you will make mistakes. And at some point, you gain confidence. And it's true that science is all about facts, but what makes it so special is the human part. So this is why we also have to trust our gut sometimes, but of course sticking to facts.
Yeah.
So now we are done talking about the difficult side. What is your favorite thing about your work?
So there are 2 I really love. The first one is trying to understanding truth. So I'm curious, and we are on the border between known and unknown, and we would like to cross this border. So this really pushes me. But also collaborating with my co-authors and colleagues is so nice when we are at the board and no one actually knows, but we all try something and we discuss, and some new idea arrives. This is very beautiful.
I agree about it's all about the collaboration and having different perspectives on it, and we are in the in the perfect place to ask questions that no one ever asked before. Ista.
Yeah, that's
Yeah.
right.
So now our iconic final question of this segment. If you could give any advice to teenage Giovanni when he was already so into math and so fascinated by prime numbers, what would you say to him?
Yeah, probably to first to read a bit more, and also maybe even in school to try to already talk to people already doing maths and ask them about what they were doing. So I I started doing this job without knowing how it was actually. So
So, if you would go back in time, you would have welcomed some insights on being a mathematician.
yeah, there were like conferences in the University of Pavia in my hometown, and maybe I should have gone there and see a bit more how it was and getting some impression.
And very importantly, this is exactly what this webcast series is for. So if you guys have any of these questions, not only about math, but other areas of science, do reach out to us and you will get insights on becoming a scientist.
Yeah, with pleasure.
So thank you so much for telling us your story. It was really my pleasure to have you here and to learn how you became a mathematician and to learn a lot about kinetic theory. And now it's time for our game show segment. We will play this or that.
Okay.
This means that I will ask you some questions that have two plausible options, and we will see how many you get right in 1 minute.
Mhm.
And for today's theme, we will let your luck, decide it. We have these 3 different options. So, go ahead.
This one. Yeah.
And today, our theme will be in a lab or in my house. So I will give you different items and I will ask you, is this in a lab or in my house?
I see. I'm ready.
Good. Okay, so without any further ado, let's start. We have this sand clock to control our time. So let's do this. 3, 2, 1. Microwave oven.
In my house.
Also in my house, but I was looking for in a lab because, for instance, when you prepare plates to grow bacteria, you have to prepare the media in the microwave. So this is what I was going for.
I didn't know that.
Kitchen sponge.
Both. In the lab.
Yeah,
let's
yeah,
say.
correct, correct. Because a lot of experiments generate, unfortunately, dirty dishes. A ring light.
In my house.
Correct. A Sharpie.
Sharpie. Oh, this I don't know what it is actually. So.
A marker.
A marker. In the lab.
Correct. It's important to identify the samples. Stanley cup.
In the lab.
Unfortunately, our time is gone, but while it's important to keep hydrated, you should not eat or drink in the lab. So this goes for the in my house.
I see. I see.
But I think you did quite well. So thank you for being such a nice contestant. You got most of them right, and I have to say that they were not so easy.
Oh, thanks.
And you are not from the wet lab, so even harder.
Yeah,
so
very hard.
So considering that you did super well,
Thanks.
and I have some things for you, some things to remember us by.
Oh,
I would like to invite you on a tour to the Vista Science Experience Center.
thank you very much. My pleasure to come. I'm very happy.
Thank you. It was a pleasure to have you here. And to you on that side, thank you for joining us once again. Be a part of our community and leave a piece of your mind in the comments. Don't forget to subscribe to our channel so that you don't miss a bit. I will continue to be here and bring you the next generation of science. So far we had biologists, chemists, mathematicians, physicists. So stay tuned and see who comes next. And until then, remember to read a lot, reach out to other people who are already more experienced and can give you insights on maybe your future career. And most of all, don't forget to have fun. Ciao!